Okay, here we go. Let's do 7.3, which is called the shell method. We've been talking about finding volumes of solids of revolution, and we've used disk method and washer method, right? When we've used disk method and washer method, the rectangles that we've been using have always been perpendicular to our axis of revolution. For example, if our axis of revolution was the x-axis, then our rectangles were up and down, vertical. They were perpendicular to the x-axis. Or if our axis of revolution was the y-axis, then our rectangles were horizontal, perpendicular to the y-axis, right? But the rectangles don't always have to be perpendicular. They can be parallel to the axis of revolution. That's what we're going to talk about today, called the shell method, where our rectangles now are going to lie parallel to the axis of revolution or the axis of rotation. Okay, when we're doing the shell method, if you think about your axis of revolution, if we have our axis of revolution here, and then we have our little rectangles up on top, and we rotate that around, it's not going to look like a disc anymore. It's not going to look like a washer anymore. It's going to look like what they call a shell. Okay, kind of like a cylinder with a hole drilled in the middle of it. Okay, we still have to find the volume of this picture. So let's go ahead and do that. And let's talk about how we would find the volume of that shell. Okay, kind of like a washer. There's a hole in the middle, so I can't do the volume of the whole entire thing. And I can't just do the volume of the inside. I've got to kind of do what we did with a washer, where we find the volume of the outer part, the outmost part of our shell, and subtract out the inner part, or the hole, right? And so if you look at this picture, what we're going to call h is our little heights of our rectangles. Okay, so if you see this is our little h, or our height of our rectangles, how high our rectangle is. They're going to call p the distance from the axis of revolution up to the center of your rectangle. Okay, they're going to call w the little width of your rectangle. They're going to call w the little width of your rectangle. So if I want to do the volume of the outside one, I want to do pi r squared h, right? Pi r squared h. So I'm going to do pi, we need an r squared and an h, okay? And if this is my outer one, then I want to go, let's see if I can do another color. I want to go from the axis of revolution all the way to the very top, okay? All the way to the very top is going to be p, the distance from your axis of revolution to the center of your rectangle, but don't I have to add a little bit more to get all the way up to the top? Because p is just from the bottom to the center. I need to go just a little bit more. Well, how much is that little bit more? Wasn't it half of the width of the rectangle? We need to go a little halfway more. So I'm going to call my radius then p plus w over 2. So that's p, which is again the length from the axis of revolution to the center of my rectangle. Then I need to go halfway more of the width. Okay, so that would be my pi r squared h for the big cylinder. Now let's talk about the little part, or the inside part, okay, where I want to subtract. So I still want to subtract, and I want to do the volume of the inside part. So I'm going to still do again pi little r squared h. Okay, let's talk about the little radius. If I want the little radius, I want from the axis of revolution up to the very inside part. Okay, if I choose p, remember p is from the very bottom up to the center. Well, I don't want to go up to the center. I don't quite want to go up that high. I need to go back down a little bit. Well, how much do I need to go back down? Wasn't it the second half of my, or I guess if you want to say first half of your width of your rectangle? So I'm going to call the little radius p minus w divided by 2. P minus w divided by 2. So this formula is going to give me my volume of my shell. Okay, kind of complicated. What you can do though, if you wanted to, is FOIL this all out, combine like terms. If you don't believe me, you can do it yourself, but you should end up getting 2 pi p h w. 2 pi, that's just a number. P again represents what? From the distance from your axis of revolution to your rectangle. H represents what? the little heights of your rectangles, right? How tall are they? And then W is the widths of your rectangles. How thick are they? If we have a whole bunch, an infinite amount of little shells, and we want to use it to help us find the volume of our solid, we're going to then integrate this. And it depends on which way your rectangles are lying. Are they lying with respect to x? Are they lying with respect to y? And then you would integrate it, right? So let's take this formula and convert it to an integral. We've got our 2 pi. It's purple. We've got our 2 pi out in front. We've got our p, which is our distance from our axis of revolution to our rectangle. We've got our h, which is the heights of our rectangle, and then we've got our delta x or delta y. Okay, so depending on how your rectangles are lying, we either need to do vertical with respect to x, or we need to do horizontal with respect to y. So if your axis of revolution is horizontal, that means your little rectangles are going to be horizontal, and that means you're doing it with respect to y. Your function should be with respect to y, all your variables inside should be with respect to y, and then your limit should be with respect to y, from your lowest y limit to your highest y limit. If your axis of revolution is vertical, then your rectangles are going to be parallel, so they're also going to be vertical. Okay, and so our information, our function, our variables should all be with respect to x, and then we're doing it from our lowest x value to our highest x value. Okay, so remember that p is your distance from your axis of revolution to your rectangle. So how far am I going from here to here, or from here to here, depending on where our axis of revolution and our rectangles are. So the distance from your axis of revolution to your rectangles, and then h is your height of your rectangle. So how high is it from here to here? Okay, how high is it from here to here? Okay, which corresponds most of the time to your function, but we'll have to kind of see. Every little problem is different. So let's do some examples here. All right, here's example number 1. It says to find the volume of the solid of revolution formed by revolving the region bounded by y equals x minus x cubed and the x-axis from 0 to 1 about the y-axis. Okay, so what we should do first is kind of graph a picture. If they don't give you a graph, you should probably graph a picture so you can kind of visualize what's going on. We have this function, and it starts at 0, it goes up and down, and it touches there again at 1. We have our axis of revolution, which says about the y-axis. So my axis of revolution is here. If my axis of revolution then is vertical, is my y-axis, then which way do my rectangles lie if I want to do the shell method? They also lie vertical, right? Straight up and down. So here are my little rectangles. Okay? All right, if I want to do the shell method then, and I want to find the volume of this shape, I want to do my 2 pi p h w. Okay, let's convert that into an integral. So here we go. We've got our 2 pi. Can I just put that in front because that's just a number, right? Let's do our limits of integration. So let's figure out if we're doing it with respect to x or with respect to y. Okay. If my rectangles are lying up and down, am I doing it with respect to x or with respect to y? With respect to x, right? So what are our x limits? It looks like we're going from 0 to 1. So I'm going to say 0 to 1 on the x. We've got to do p, and what did p represent again? P represented the distance from my axis of revolution over to my rectangle, didn't it? So I want to go from my axis of revolution over to my rectangle. If my rectangle is right here, I want to go from my axis of revolution over to my rectangle. So depending on where my rectangle is, or I guess I should say no matter where my rectangle is, what does this little distance correspond to? Here and here. Doesn't that just correspond to where I am on the x? Right? So if I'm over 7, then the distance is going to be 7. If I'm only over 2, then my distance is only going to be 2. So the distance from my axis of revolution to wherever my rectangles are should be just whatever the x value is. Okay, so p represents x. All right, so let's do h. And what does the little h represent? Doesn't little h represents the height of my rectangles? So depending on where my rectangle is, what is going to be the height of my little rectangles? Isn't it just going to be whatever my function is at that time? So what is my function here? X minus x cubed. And then my w, my little widths of my rectangles, are just my little dx's or delta x's. Okay, so now I have my integral set up. What I'm going to do to integrate this is probably just distribute this x through, making it an x squared minus x to the fourth dx, integrating it still from 0 to 1. Don't forget about your 2 pi in the front. So when I go to integrate, I have my x cubed over 3 minus x to the fifth over 5. I want to integrate it from 0 to 1. Don't forget about your 2 pi in the front. Okay? All right, if I evaluate then and I plug in my 1, I get 1 third minus 1 fifth. Minus, if I plug in my 0, don't I just get 0 everywhere? Don't forget about your 2 pi in the front. Getting a common denominator of a 15, what's that? 5 minus 3, 5 fifteenths minus 3 fifteenths, that's 2 fifteenths, right? And don't forget about your 2 pi in the front. So what's 2 fifteenths times 2 pi? 4 pi fifteenths? 4 pi fifteenths would be your volume of your solid of revolution using the shell method. Okay, let's do another one. All right, here's example number 2. It says to find the volume of the solid of revolution formed by revolving the region bounded by the equation x equals e to the negative y squared, the y-axis from 0 to 1, about the x-axis. Okay, so let's visualize what's going on here. We've got our little function. They gave us a picture of what it looks like. Our axis of revolution is the x-axis, so my axis of revolution is here. If I want to use the shell method, which way do my rectangles lie if I have an axis of revolution that is the x-axis? They also lie horizontal, right? So if my rectangles are horizontal, I'm integrating with respect to who? With respect to x or with respect to y? With respect to y, right? So when I go to find the volume using my shell method, I've got my 2 pi. What would you say our limits of integration is then? Are we doing it from the y? What's your lowest y? If you stack, oops, what did I do there? Oops. Okay, sorry. If I stack up my little shells, I'm going to go from 0 on the y to 1 on the y, so 0 to 1. I have a p, which is the distance from my axis of revolution up to my rectangles. My axis of revolution up to my rectangles. What do I keep doing here? Axis of revolution up to my rectangles. No matter where my rectangle is, how long is this distance going to be? Isn't it just going to be what it is corresponding on the y? So if I'm up at 3, then my distance is going to be 3. If my rectangle's up at 12, then my distance is going to be 12. So it all corresponds. P, my axis of revolution to my rectangles, is just going to correspond to whatever my y value is. Okay, now let's talk about my h, my heights of my rectangles. Okay, if I want to figure out the height of my rectangle, I want to figure out how far is it from here. Oh my gosh, from here to here, right? From here to here if my rectangle's there. What does that always correspond to? Doesn't that always correspond to my function? But my function with respect to y, so what would my h be? Wouldn't it be e to the negative y squared? So that's nice that it was already set up for us. And then I just have my little widths or my dy's. Okay, so that's my integral. Now we just have to integrate it. This looks a little tricky though with my e to the negative y squared. So we might have to do a little bit of u substitution. Let's try some u substitution. If I need to do u substitution, what do you think we're going to call u? Let's try our negative y squared. So then if I call u negative y squared, that means du is going to be negative 2y dy. So we have a y, we have a dy, we just don't have a negative 2. So can I put a negative 2 in there? If I put a negative 2 in there, then I have to balance it out with a negative 1/2 outside. Look at those 2's, those are going to cancel, right? Okay, so I have a negative pi from 0 to 1 of e to the u, oops, e to the u du. What is the integral of e to the u? Isn't it just e to the u again? But what was u? Negative y squared? Okay, from 0 to 1, don't forget about your negative pi in the front. Okay, if I want to evaluate, I want to evaluate e to the negative 1. E to the negative 1, can I bring that down and just make it 1 over e to the positive 1? Minus, if I plug in a 0, I have 0 squared is 0. What's e to the 0? What's anything to the 0? 1, isn't it? So I have 1 over e minus 1. Don't forget about your negative pi in the front. To me, that's pretty simplified. So if we wanted exact values, we can leave it like this. If you wanted it in decimal form, you can put it in your calculator. You should get 1.986 would be the volume of a solid if we took this and rotated it around the x-axis. Okay. All right, so let's walk through one more time the difference between disk method and shell method. We've done disk method in the past, or you can also call this washer method if there's a hole in your little disks. And we use disk method and washer method when our rectangles are what? Perpendicular to our axis of revolution, right? So if our axis of revolution was the y-axis, then our rectangles would be horizontal. We would have to integrate it then with respect to y. We would have to figure out what our radius is if it was disk method. We would have to figure out what our big radius is and what our small radius is if it was washer method, right? And we would do pi r squared h. If our axis of revolution was horizontal and we were doing disk or washer method, then our rectangles would be vertical, perpendicular, right, to our axis of revolution. We would then be doing it integrating with respect to x. We would have to figure out what our radius was if we were doing disk. We would have to figure out what our big radius is and our small radius is if we were doing washer, and then we would have to integrate it using our pi r squared h. Okay, that's disk and washer. What if we were doing shell though? Let's review one quick more time about shell method. If our axis of revolution was our y-axis, then which way would our rectangles lie if we're doing shell method? Wouldn't they also be vertical, straight up and down? And so if we're doing shell method, remember we need to do our 2 pi p h w. 2 pi out in front, what does the p represent? The distance from our axis of revolution to our rectangles. So in this case, it would be just whatever we are on the x. H is the height of our rectangles, right, with respect to x. And then you'd integrate it using your 2 pi p h w. Well, what if our axis of revolution was horizontal? If our axis of revolution was horizontal, maybe it was our x-axis, then which way would our rectangles lie? Wouldn't they also be horizontal? Okay. We would have to use our shell method again, which is 2 pi p h w. P representing from our axis of revolution up to our rectangle. So depending on what this is, depending on where our axis of revolution is, it's not always going to be x or y. They're going to change it around on us a little bit, but it's from our axis of revolution up to our little rectangles. Okay. In this case, it's with respect to y. So if we needed to find our little heights of our rectangles, we would need to figure out what our function is or what it is from here to here. So again, it might not always even be our function. We might have to add, we might have to subtract, we might have to find the distance in between, so you've got to be careful. They're always going to be just a little bit different. Okay? Distance from our axis of revolution to our rectangle is p, the height of our little rectangle is h, and then our little widths of our rectangles, so we're doing it in this case with respect to y. Okay, sometimes the shell method is going to be much easier than the disk method or washer method. Sometimes our washer method is going to be a little bit easier than our shell method. It just depends on what you like best and what your picture looks like. On your tests, I will allow you to choose whatever you like. You just have to make sure that you're using your setup correctly, integrating it correctly, all that good stuff. Okay. What I suggest you do as you're working through your Chapter 7 review is do both for each question if you can. That way you can practice both methods of all different types of shapes with respect to X, with respect to Y, all that good stuff. Okay. All right, we have a few more examples we'll do in part 2, and then you can work on your 7-3 homework when you're ready. Don't miss me too much. I'll see you later.